Hello, welcome to building a web application using ASP.NET Core 1.0, Node.js, Aurelia, TypeScript, and Webpack in Visual Studio Code, Part 6, Section 2. Before we talk about what we're going to do in this section, I would like to make sure that you guys have the latest and greatest versions of some of the tools that we've been using all along. Node.js version 6.9.0 LTS has been just released. Please download it from their website and then have it installed. Similarly, Visual Studio Code 1.6.1 is also available for download. Please have it downloaded and installed as well. And then there is an Aurelia plugin for VSCode, which is available at this link. Or if you just Google for VSCode Aurelia plugin, it should take you to this page. Please download it and install that as well. Okay, what are we going to do in this section? We're going to take the application class that we built in our previous section, and then we're going to refactor it into its own router class. So what I'm going to do is I'm going to create a folder named routes, and then I'll create a router each for each of those frameworks: Express, Restify, and Happy. So the first router that I'm going to create is called Express Contact Router.ts. And what I'll do is I'll take some of the imports from my application class, and I also take all those properties that are part of application class into the router class so that the router can live on its own and application can leverage the router class. So let's just copy this whole thing and then we'll move into the express contact router, and then we definitely don't need this. Let me delete the things that we don't want, and then we want to call this class express contact router, and we don't need any of those, and we don't need this as well. All that we want is to get the we want two properties, one for the contact router, another one for the contact service. They are of type express.router and in-memory contact service. And then in the constructor, we will just create an instance of them. Okay, I'm going to take the code. I will probably copy it from Express application class itself. So here I have these two lines. I'm going to copy them and paste them into this constructor. Okay, so let me close this class. So we're going to move some more methods from our Express application class. Let us take these two methods that are useful for configuring the error routes and the API routes. One of the things that I wanted to do is in Express framework, always the error route has to be the last one, because if you look at it, it is no different than any other handler. The only difference is that it doesn't give any URL. So this is the fallback. When nothing matches, it'll come to this handler and then it'll throw an error saying that, hey, it's HTTP 404 not found. So what we want is we want to just take this code, but when we call them, we want to call the API routes first, followed by the error routes. If you flip them, you may not even get this 404 error. So this is another small problem that I introduced, which can be easily fixed by calling them in the right order. Okay, so I'm going to take this code. Let me cut it instead of copying it because we will not need it anymore. So I'm going to move that into this class, and I'm going to make them public because it has to be called from the application class. So I'll make it public. And also, if you see that it is using the Express application, which is a member of the Express application class, but now since I refactored it, I want to pass it as an argument to those two configuration methods. I will tell you why I'm doing this when we talk about dependency injection. Because if I make this as a dependency on router and the router depends on application, you will get into cyclic dependencies. That's why I would rather pass it as an argument. So what we'll do is we'll just copy this part of it because this is going to be helpful, and we will make that as an argument. And we'll remove this keyword reference because now it's coming as an argument. Similarly, we'll do this here as well. Cool. Now that we've built our router class, what we want to do is we want to create an instance of this inside of our application class. So I'm going to um, delete these two properties, or maybe I will just, make this as we'll call this property is type as express contact router because that's what we need, and we just need to import that. So let's import that, and then we will new that up. Okay, so we no longer need this call because it's now part of the router, and this is going to be a member of the contact router. As you know, it now takes an additional argument which is called express application. So I'm going to take that and paste it over here. Similarly, we will call the API route. Like I said, we are going to swap the order because this is not the right order. We want the error routes to be the last and the API routes to be the first one. So I'm going to cut this line and then paste it above this. Okay, so now we don't need these needless imports. So I'm going to delete them. And body parser is also not required because that's useful when we implement the post, put, and other methods, which we are going to implement now. So let me go back to the contact router class. And what I want to do is I'm going to just take the code from the completed application and I will explain that quickly. So right after we have defined the get method, what we want to do is we want to define the other methods as well, like the post, put, and delete. As you can see, post method, the parameters are always the same, the request parameter and response parameter, but what we do inside is what matters. Inside of that, since we've already built the in-memory contact service, we're going to delegate that the post to the save helper method, and whatever comes in the request.body goes in as an argument. In the body, we're going to get new contact JSON structure, and then we'll pass that into that helper method or into that service method, and then the service method save will persist into that in-memory array. Similarly, for the put, we're just going to overwrite whatever the information that comes in the body. We're going to pass it on to the save method again, and it's going to override it. The save method is smart about it. If it doesn't exist, it'll create. If it already exists, it'll overwrite. Similarly, the delete method is going to delegate to the delete method of contact service, which in the body will pass the ID of the contact to be deleted, and then it'll locate the ID and delete that element from the in-memory repository. It's very straightforward. So we now have implemented the get, post, put, and delete. And we have refactored our routes from the Express application into the Express contact router. Now let's make sure that it is going to work like the way we want. Before we run this application, what I wanted to do is to make sure that we have specified Express as our REST framework. Okay, so everything looks good to me. And let me press Ctrl Shift U to see if there is any errors from TypeScript transpiler. We noticed this error in the last section, but this is not really any error because output is a dynamic property, and the TypeScript type definition for happy doesn't have that defines it, which is why it's complaining. But you can ignore this error. It's going to work because at runtime the output has some valid value. Okay, with that said, now let us make sure that we can hit F5, or we can click on this debug and we can click on this green play button, and let's see if it is able to launch the debugger. Okay, so let me single step and we'll go into the Node.js framework factory. Okay, we are calling the contact router instead of the config API routes and config error routes that were earlier private members of this application. We now separated them into a router class. Okay, now I'm going to hit go, and I'm going to put a breakpoint in the get method. I'll put the breakpoint in all methods because we are going to hit all those methods one by one. Okay, so hit go, and let me open up the browser. Well, because get request is very easy to make from the browser. Okay, let's see which breakpoint is hit. As you can see, it now entered into our router class. And this is going to call the get all helper method and return those four hard-coded contacts that were defined inside the in-memory repository. Okay, there we go. But for testing the post, put and delete, it's impossible to do them from the browser unless you have a form defined. So I'm going to use the Postman tool. I'm going to open that up, and we're going to test a post method by creating a new contact. I'm going to, since I've already done that, I'm going to click on this. If you are new to this, you can watch previous sections where I've showed how to use Postman tool. The only thing that you wanted to make sure is you set the header to the header content type to application/JSON, because we're going to pass the JSON structure of the contact inside the body, and inside the body you want to create this JSON structure. And I'm creating a new contact with a new first name, last name, email address, phone number, and birth date. Now if I hit send, it should hit the post method. Okay, here we go. And you can check the request body, whatever we passed. I'm going to dock it on the left side and right side to show you. Okay, so here, if you mouse over that body, request.body, as you can see, whatever I passed from this Postman tool is what is being received from the request.body. So I'm going to hit go. It's going to go and persist it. How do I know it is persisted? We're going to make another get call, get request, and see if the fifth contact is being returned. Let's go to the browser. We can hit refresh, and then it comes to the get all method, or the get method, and which delegates to get all. And then you will see the new record that I added is at the end. Okay, so now let's go ahead and modify one of the records. For example, I'm going to modify this contact with the ID name 4. Instead of the name Mahati, I'm going to change it to Cutie. Let's see if it works. And I'm going to go back into this tool, and I'll maximize this. And there is a put call that I already made. As you can see, I'm passing the ID as 4, but I'm changing the first name, and I'm going to click send. It's going to hit the breakpoint in the put method, and you can mouse over and see that my first name is going to be Cutie. I mean, the first name of the contact is going to be Cutie instead of Mahati. And we'll hit go. And instead of using the browser, we're going to use the Postman to get all. So I'm going to click on the get method, and then I'm going to click send. It's the same thing whether you call it from the browser or any other tool like Postman, Advanced REST Client, or Fiddler. As long as the client can make a request with the proper HTTP verb, it'll hit the appropriate method. So you can see that it returns all those 5 contacts, and then the first name has been changed from Mahati to Cutie. Now I want to delete one of the contacts. How about I delete this ID1? So I'm going to go to the del, and in the del HTTP verb, delete HTTP verb, the header is the same, but the body is going to say ID colon, what is the ID of the contact that I want to delete. If I delete the first one, it's going to just go to the delete helper method, and then it's going to delete that item from the in-memory repository. And now if you do a get request, you will see that the first name of the very first contact in the list of contacts is gone. So I'm going to go back to the get method one more time, and I'm going to click send, and I will hit go from the debugger, and you can notice that ID1 is gone. It starts with 2, 3, 4, 5. So that is how you take the routes from your application class, and you can create your own router class, and then you can leverage it. Just as how we did in the Express framework, we'll do exactly the same thing on Happy and Restify as well. Let us start refactoring the Happy application into the Happy contact router, and then we'll start using that router inside of the Happy application. Let me open up the Happy application.ts, and I will copy the import as well as this declaration. Just take this whole thing into a new class named happy-contact-router.ts. Okay, we'll paste the import, and I think we don't need this node Node.js, and we want to call this class happy contact router, and we don't need the happy server, we only need the contact service. And inside the constructor, we will create an instance of that contact service, and we'll copy that from happy application. Okay, let me delete this because we can do a cut instead of paste, instead of copy and paste. Okay, let me close this method, and I will also bring these two configuration routes method, config error routes and config API routes. Change them to public and pass the happy application as an argument, like how we did for Express. Just take this definition and paste it as an argument. Remove the this reference. And we will need to copy the post, delete, put methods from the completed application. So I'm going to take the completed application. I am going to take the code and paste it. So this is how it's going to be done. So I'm going to define a variable called endpoint and use it. Oops, sorry, I should have put it in the config API routes, not in the config error routes. So I'm going to get that post, put and delete method definitions. I'm going to paste it over here. Okay, so now that we have the routes helper methods defined, we're going to create a property of type happy contact router inside happy application. We no longer need this. Okay, I'm going to define a property of type happy contact router. And then we'll create an instance of that. We need to bring the import. We need to import that module using the import statement. Okay, now we are going to make a call into those methods that are defined now inside of the config happy router or happy contact router. So I'm going to copy that. I'm going to call it using the happy contact router, and then the argument is going to be this dot happy application. We'll do the same thing for the other config API routes as well. In here, the order doesn't matter, but to be consistent, I'm going to swap the order. First, I'm going to call the API routes, then I'm going to call the error routes, just to be consistent. So let me cut this 2 lines, including the comment, and then paste it above this. And delete these two methods because we've already moved them into the happy contact router class. I think we're all set, and we don't need this needless imports because they are now part of the happy contact router class. Okay, now that we've done with it, we'll go ahead and change the framework to happy using the launch.json, and let us put a breakpoint inside the happy contact router's get method. Post, the breakpoints won't be there because we haven't restarted the application yet. So once I restart, they'll all become active. See, they are all active now because TypeScript has already transpiled it, and then the breakpoints are coming back to life because there are no compiler errors. So let's give go. Okay, first let's hit the simple get method from the browser and see if it goes into the happy contact routers get method. There we go, happy contact router in the get method. It's going to return those 4 hard-coded contacts, and you're going to see the value. Okay, now let's play with the post, put and delete from the postman. It's exactly the same. We're going to replay the same request. So I'm not going to explain that since you already explained it, and you know what I'm doing. So I'm going to create this new contact. So it'll hit the post method, and then it's going to add this new contact. And when you call the get, you'll see that fifth contact that I added right there. You have this contact that I just added. Similarly, the put method, I'm going to replace one of the records, one of the first name from Mahati to Cutie, and I will do that here, and it hits the put method. Okay, now if you replay the get method, you're going to see that the first name has changed from Mahati to Cutie right there. And then the last one is the delete, which I'm going to delete the ID, a contact with the ID 1. So I am going to delete the first record, and that calls the delete method. And then if I replay the get method, I'm going to get only 4 contacts. The contact with the ID 1 is no longer there because I deleted it. There we go. So that is how we wire happy application. Let's quickly wire Restify as well. So let's go back into the roots folder, create a Restify dash, oops, let me hit rename, Restify dash contact dash router.ts. We'll follow the exact same steps. I'm going to copy the imports first. I'm going to copy the constructor as well. And I'll paste it into the Restify contact router. And in here, I really don't need this. And I need to call this Restify contact router class name. And we can just say it's the Restify contact router. Then we'll move we don't need this I Node.js. We're going to move the config methods, the API routes and the API routes and the error routes method from Restify. Okay, let's copy these two. Actually, since I don't need them, I'm going to cut it and paste it and change this to public. And as we're going to take the parameter of Restify application, so we'll copy it from here. Okay. And remove this because it's no longer a property, it's coming as a parameter. Okay, and then once this is working, now we need to get the other HTTP verbs like post, put, and delete. So I'm going to take that from the completed application. Okay, there we go. And then we'll put the breakpoint, even though the breakpoint won't be active until I restart Node.js. Let me put the breakpoint. And then let's go back into the application class and start using this new router. So I'm going to change the, I'm going to declare a variable called Restify contact router. That is of type Restify contact router, and we need to import that. Pretty much the steps are same for all 3 frameworks. So, and we no longer need these two. We'll delete them, and we'll create an instance of this inside of the constructor. And then we'll call the configuration routes methods to be consistent. We'll also swap the order. We'll call the API routes first, followed by the error routes. So I'm going to take this Restify application, make this an argument. Same here. We'll do this as well and pass the Restify application as an argument. Then let's swap the order by cutting and pasting this code above the error routes. Okay, we no longer need this because we are defining that service in-memory service inside of the router class. Okay, now this is also refactored. Now that it is completed, what we can do is we can go to the launch.json, change this to restify, and we already put the breakpoints. I'm going to restart the Node.js, so it'll pick up the changes. Okay, let's hit the get method one more time, hit send. It should hit the restify contact router this time. There we go. And similarly, we'll play the post. So a new contact will be created. And we can verify that by running the get one more time. You can see that the fifth contact is added. And then we'll use the put to change the name from Mahati to Cutie. One more time. After every change, always make a get call to make sure that the changes are made properly. And you can see that, yep, it's changed. And then finally the delete call to delete the first contact. That's the contact with the ID 1. So that's the last one. And we'll call this. Let's go back and call the get one more time just to make sure that the contact with the ID 1 has been deleted from the in-memory repository. There we go, it's all gone. So now we have isolated the routing code from the application class into their own router classes for all three frameworks. Okay, next we will introduce the Aurelia dependency injection container on the server side, that is on Node.js, and then we will introduce a different startup class, and that will initialize the Aurelia's DA container, and from there it will automatically inject the instances of all these required dependencies instead of us having to explicitly say new and the class name. Okay, let me first install the Aurelia's DI module. Since Aurelia's DI module uses the Reflect API, we need the Aurelia polyfills as well. So we're going to install those libraries using npm install, and we will install both the modules with the dash dash save flag so they get persisted into project.json. Okay, so after it's installed, we'll start using them inside of our application. While it's being installed, let me go back, switch to Visual Studio Code, and let me stop the debugger. I'm going to go inside the DI folder that I already created and create a new class named Aurelia-DI-container.ts. Okay, and then I'm going to import the Aurelia polyfill and the container modules. Like that, and we'll also need the Node server class. And then I'm going to create the class now. Export class Aurelia DA container. And then I am going to create a static method named bootstrap. This is the convention that I follow. And then I am going to create an instance of a container, an Aurelia container. Then I'm going to get an instance of node server using the container.get method. Container.get and the type of the method and the type of the class, which is node server. And then we're going to call node server.bootstrap. Okay, and we need to create an instance of Aurelia. We don't need to create an instance because it's a static method. We're going to use the class name dot bootstrap. And by now we must have guessed that this is going to be my startup class from now on instead of node server. Okay, is that enough? Yeah, this is good enough just to start the node server. But remember, if you go to the node server class, Node server uses Node.js framework factory. So right now that is also being newed up in the constructor. If you remember, one of the main reasons why we introduced the DA container is to inject them without having to explicitly create using the new call. Before we forget, let me go into the launch.json and then change the starting program. So right now it's pointing to server source node server.ts, but we no longer need that because we are going to start from another class called Aurelia DA container that is going to create instances of other classes and inject them. So that is in source contact manager folder, and then the name of the class and the DA folder, and the name of the class is Aurelia-DA-container.ts. Now that is going to be the startup class because that will bootstrap the Aurelia DA container. From the container we can get the node server, and from node server we can get all the other classes because we are going to inject them into node server now. So now let us change our focus into the Node.js framework factory. We need to refactor that code. Okay, so in here we are explicitly newing up all these applications. As you might have guessed by now, we're going to inject all these application instances into the Node.js framework factory. We're going to use Aurelia's inject decorator. Um, Decorators are a new feature in ECMAScript 7. So in order for us to use decorators, we need to add the experimental decorators setting to true inside of our tsconfig.json. So the first thing we'll do is we'll go to tsconfig.json. Oh, I already added it for you, so you can just type this and use the autocomplete. For example, if you just type experimental, it brings that, and then change it to true, and that's it. It is ready to be used. So we can now use the experimental decorators. The decorator will always start with an @ symbol. So let's go back into our Node.js framework factory and we'll import the inject decorator from Aurelia dependency injection. Okay, and then like I said, we are going to inject all three applications. We've already imported them. Only difference is instead of saying new express application, new happy application, new restify application explicitly, we'll inject them using @inject followed by the parameters. The three parameters are express application instance, happy application instance, and restify application instance. Or you can put them in any order you want. As the only thing that you have to be careful about is whatever order you specify is the order in which it'll be injected into the constructor. So you need to declare a variable of type express application, restive application, and happy application in the exact same order. And I'm going to use the C sharp, sorry, not the C sharp, the TypeScript's the property declaration inside the constructor syntax. So private express application, which means that an instance of express application will be injected by Aurelia's dependency injection container into this property. Similarly, I'm going to declare a property for restify. Remember, the order matters. Then I am going to, okay, I have to declare the type of that. The type of that is express application. Similarly, the restify application, that type is going to be restify application. Okay, and I'm going to define the third parameter whose type is happy application. Okay, now that we got them injected, we cannot do this. So what I'm going to do is I'm going to declare a object and then make sure that they all get assigned into the appropriate object property. So I'm going to write a small code that uses that inspects the arguments type, and then it uses that to build this framework instance objects members. So I'm going to take that code that I already have written, and then I'm going to paste it over here. So I'll explain the code. Okay, so this dot framework instances. Okay, I no longer, this is an object type actually, not an array, because I'm using the objects array notation syntax in JavaScript. In TypeScript, you can say an object dot, or you can say object within square bracket, a string that is also technically a property of that object. So I'm going to use that syntax. So it's not an any array. It's enough if you just declare it as any, which means it's an open-ended object, and that's how you initialize an open-ended object, an empty object, and then you assign the properties using this array notation syntax. So I am enumerating the arguments. This arguments is the JavaScript's inbuilt parameter, which will contain these three arguments, and then I'm taking their constructor.name, which is going to match express application, restify application, and happy application. And by using the load dash start case method, it is going to introduce a space in between them, and then I'm going to just say express space application, and then it's going to give the type name, and then we're going to assign those values into the appropriate property inside the framework instances. Okay, so this will construct the Node.js framework factory, and what we can do now is we can go back into the Node server, and then that we'll inject the Node.js framework factory in Node server. So our goal is to not do any explicit construction. Okay. Let me go back to Node.js framework factory, because the the constructor itself has this express and application. We don't need this explicit application string, because the start case will automatically introduce a space in between. So this is we'll put a breakpoint and I'll show you how it works. Let me go back to the Node server, and then there we are going to just import the inject decorator, and then inject the Node.js framework factory. So let me import the Aurelia's inject decorator, and then we will just use the at inject decorator. And as always, the constructor has to take a parameter. So I'm going to just move this inside of the constructor parameter, and we're good. There we go. So now we've defined a container, we bootstrap that, and then we only get the Node server instance, and Node server has a dependency on Node.js framework factory, and Node.js framework factory has a dependency on express application, restify application, happy application. But if you remember, we refactored all the routes into a router class, which means that the express application has now a dependency on the router classes. So we'll do exactly the same injection there as well. So let's go into the express application, and we will put the inject keyword here, and we're going to inject the router, as well as we need the yeah, we'll just inject the router. So I'm going to just call this inject express contact router, and as you might have guessed, I'm going to cut this and make this as a constructor argument now. Because it is injected, you no longer have to new it up, because that Aurelia's DA container will give you an instance. Okay, so we'll repeat the same thing for happy as well as restify. So I'm going to go to the happy application. I'll paste the code. I will make sure that we inject the happy contact router at inject the happy contact router, and then we will cut this property and make it as a parameter into constructor, and delete the explicit construction. We'll repeat the same thing for restify. Okay, here we need to make sure that the type matches that type of the object that we want to inject. We'll take this and make it as a constructor parameter, and remember to delete the explicit construction. Okay, so now we've taken care of all application classes. Now, as you might remember, the router depends on the in-memory repository or the in-memory service. So we need to go into the router classes and inject that. So I'm going to copy and paste that. Oh, okay, I don't have it in the clipboard. So I'm going to go back and get this, at least the inject import and the inject decorator. And what we'll do is we'll take this, and that's what we want to inject. And we will move this. It's the same pattern. Once you understand this, you can repeat it over and over again. And we are now injecting it instead of constructing it explicitly. Okay, let me copy this and then do it in the happy router as well. And take this guy and make it as a constructor argument. Okay, and the last one that we want to do is the restify contact router. There also we need to inject the in-memory contact service. And we'll take this definition, put it there, delete that. Okay, what I want to do is I want to put some console.log on all these constructors so we can see that they are being printed in order. So that way you know that the injection has succeeded. Let me go and copy the same thing into Express as well. Okay, I'm sure we had the console.log on all of these application classes, but let's double check. Okay, I think it's not there, so I'm going to just add a console.log. This is just to trace and see the flow of the application. Okay, Happy already has the console log. I'm sure Restify already has it. And Node.js framework constructor also has it. Okay, now that we've completed all of this, let us give it a run. Let me see if the TypeScript transpiler is running. Yes, it's running, so I don't want to terminate it. So let it. It's compiled. On line number 35 of Node server, there is a problem. Okay, let's go back to line number 35 of Node server. And there we go. We no longer need to do this because we're doing this already in our Aurelia DA container. If you go back to Aurelia DA container, we ask the DA container to give us an instance of Node server, and we are calling node server.bootstrap. So we no longer have to explicitly define that because this is no longer our starting entry point. Our entry point has already been modified to come to Aurelia DA container. So we can put a breakpoint here, and now we can run it and see if the dependency injection worked. Let me give a go. Okay, so since we specified this as the startup class, it came here. Let me single step into that. And then you can see that it creates a Aurelia container, and it is asking for an instance of the class node server. So it's calling the constructor, and because the constructor has a dependency on Node.js framework factory, it came into this constructor, and you can see that the type name is express space application. This is the reason why I deleted the explicit space application string, because the start case will automatically take this variable and turn them into Pascal case, and also introduce a space in between every word boundary. So I'm going to hit F10 or go. So it's going to loop through all three types of application. And then this is all system code. Okay, it'll return to the caller. Okay, and we call the node server bootstrap. And that threw an error. Let's see what went wrong. Okay, so node server.bootstrap. Oh, bootstrap is misspelled as bootstrap. It's a typo. Okay, I'm going to type bootstrap, and then I'm going to relaunch it. So this time I'm going to click go because we already seen this work. Okay, let us see what did we specify as the REST framework in our launch.json. I think we put it as restify, so it's going to hit the restify breakpoints now. We can either call it from Postman or from browser. So I'm going to call it from Postman. Let's call the get method, and it came into restify contact. So our dependency injection worked like a breeze. This is one of the greatest strengths of JavaScript. Since JavaScript libraries can be run on the server side using Node.js, we don't have to, we can leverage many of the client-side libraries as long as they don't directly do the DOM manipulation or anything to do with the client-side browser. You can reuse the libraries on the server side inside of Node.js without any problem. And here's a great example of leveraging an Aurelia's DA container and Aurelia's polyfill on the server side in Node.js. Okay, now some of you might think that why am I creating the applications ahead of time? That's called eager creation. I'm eagerly creating it or eagerly loading them in Node Framework Factory. As you can see, um, I mean, we did the same thing in the other version as well, like where we said explicitly new Express application, new RESTify application, and new Happy application. But if you really want to defer that execution, Aurelia has something called as the resolver. There's something called as a lazy resolver, and you can use the lazy resolver to instead of returning an instance, the lazy resolver will return a function, and you can later call that function to get the instance of this application, Express application or RESTful application or Happy application. The only thing that you have to be aware of is when you want to use the lazy resolver, you have to import the Aurelia framework, and Aurelia framework is not really a huge library because Aurelia has a separation of concerns and it has one module per feature. So this is only the base framework feature. So let us do that now. Let me install the Aurelia framework by using the npm install command and save it. And all of our changes are going to be inside the Node.js framework factory because if you lazy initialize that, that is more than enough because that has dependencies on the Express application, RESTful application, and Happy application. We don't need to delay our lazy initialize Express application dependencies like router and in-memory repository. Those can be eagerly created. That's not a problem. But we don't want to create one full-blown Express application and one full-blown RESTful application and one full-blown Happy application object graph because we are only specifying one of the frameworks in our launch.json. So we'll have an advantage if you use the lazy initialization on the Node.js framework factory class. That's what we are going to do exactly. I guess it's already installed. Okay, it's done. So now let me go into the Node.js framework factory. I'm going to close all of the other classes just to make the screen clear for us. So I'm going to just import the lazy object, and instead of instantiating the Express application, I'm going to call the lazy.off resolver call, which will return a function instead of an instance. So I'm going to copy this lazy.off and open parenthesis. I'm going to paste it on all the other types as well. Okay, now it is, I'm going to close it. Now it is not expecting an instance, instead it is expecting a function. So what I'm going to do is I'm going to call this get express application instead of express application, and it's going to be a function definition. So I am going to copy and paste the function definition from the completed application, and I'll explain that. Okay. Okay, as you can see, I'm defining a function that returns express application, a function that returns RESTful application, a function that returns happy application. That's what the lazy.off call will return. It will not return the instance. Instead, it'll return a function that can return the instance of the given type inside the lazy.af parenthesis inside the lazy.af methods parameter. So we define three lazy evaluation functions for express application, restive application, and happy application, and those functions will be injected into the constructor. So we are storing the functions directly. As you can see, I defined a hard-coded value for the keys of my object, and then I'm just calling them, just pass the argument. Argument is of type function. So we are storing the functions, and here what I'll do is I have to, instead of returning that, I have to invoke the function so that it will return the actual object type. So when somebody is calling create Node.js framework with the express, I'm going to turn that into the express space application, which will go into this framework instances object and returns that function. And then if you invoke it using this open parenthesis, close parenthesis, it's going to return the object. So if it happens to be, if the REST framework's value happens to be express application, it's going to call get express application function with this function execution syntax, and it's going to return an instance of express application. Similarly, it's going to do the same for restify and happy. So that is going to be efficient, because if you can see now, I will go back to the launch.json, and let's say we change it to express, right? And then we will put a breakpoint in the Node.js framework factory, just to show you that it has only the function stored, not the actual instance. So I'm going to restart the Node.js server. Okay, bootstrap the container. Here we go. So it's going to ask for Express framework. And if you look at the framework instances, you can see that it has three functions instead of three instances. So Express application is technically a function. So, and then when we are calling the function, you can see that it'll return the instance of the Express application. So I just single stepped. Okay, now this would have returned a type Express application. As you can see that. There we go. Now we have not created an instance of happy or restify because they are still stored as functions. But if you go back and if you stop the server, change the launch.json to use restify or happy, it will create an instance, and it's all completely lazy loaded. Now that concludes section 2 of part 6. In this section, we have seen how we can extract the code, the router code out of the application class into their own classes first, and then later we brought in the Aurelia's DA container, Aurelia polyfill to use the at inject decorator, and finally we introduced the lazy resolver to show how we can lazily create the object instances based on the lazy.off call. Then we can just run it just for the sake of completion. So I'm going to just call the get method, and it's no different whether you lazy initialize it or you eager initialize it, the result is the same. Thank you until we see in another part. Happy coding.